Hi everyone, welcome back to NoSkit. So let's solve one of the very interesting question of LinkedIn from Uber 52 frequent questions. So let's see what the question says and how we can approach that question. So today we are going to solve merge two sorted list. So you are given the heads of two sorted lists, list 1, list 2. Merge the two lists in a one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged list. Right. So first let's understand the problem, what the problem says, and then we'll see how we can solve that problem. So in the question we have two linked lists given, list 1 and list 2. Right. List 1 is sorted and list 2 is also sorted, and in the result what we want these lists to be merged in a sorted manner. How? 1 1 2 3 4 and 4. This is what we want in our result. That means given two sorted list and we want to merge them into one sorted list. So if you will see this, the resultant list should be sorted. Now how we can approach this problem? So first, very intuitive approach can be that we have two lists, right? We have two lists and both the lists are sorted. Both the lists are sorted at their individual level. So what we can do, we can traverse this list 1 and we can store the elements of this list 1 into one list, right? And then finally we can traverse the list 2, and then we can also traverse the list 2 and we can append the elements of this list 2 into the same list. So let's see. So let's say we started traversing list 1. So we have 1, we stored 1 into our list. Then we have 2, we stored 2 into our list, and then we have 3. Then we have 4, we stored 4 into our list. So the list state will become this, right? Now after traversing the whole list 1, we'll come to this list 2. Right? Now we'll again traverse this list 2, 1, then we have 3, then we have 4, right? So we'll append the data of this list 2 into the same list. So now we have this list, right? Now what we can do, we can sort this list, right? And we can create one new linked list with the sorted data, right? So what we did, given two linked lists, list 1 and list 2, we stored the elements of list 1 and list 2 into a list. Finally we sorted this list, right? And then finally after sorting the list, we converted the sorted content into a linked list, and finally we returned the head of that sorted list, right? But now how much time did we take to did all the process? Let's say each list can contain n elements. Each list can contain n element. That means list 1 can contain n elements and list 2 can also contain n element, right? So what we did, we traversed both the list. So n for traversing list 1, n for traversing list 2, right? And then finally what we did, we had 2n elements into this list and we sorted it. So 2n log 2n, right? So we can ignore constants. So final time complexity for this approach will be n log n, right? And how much space did we take? This will be the time complexity, right? How much space did we take? So now we stored all the elements of list 1 and list 2 into a list. So let's say we have n elements for list 1, n elements for list 2. So now we can ignore the constant. So the space complexity for this approach will be O of n, right? But if you will see, this is n log n approach, right? So after this, your interviewer will say, can you try to optimize this? Can you try to optimize it further? So after log n approach, you should come up with something which is lesser this n log n. So let's discuss the second approach. So let's see how we can do it, in a more optimized manner. So we have two lists, list 1 and list 2, and we want a list which is a sorted list in the resultant by merging these two lists, right? So now what we can do, let's maintain two pointers. Pointer 1, pointer 2, right? Pointer 1 is pointing to list 1 and pointer 2 is pointing to list 2. I am saying let's create one dummy node. Let's say the content of dummy node is -1, right? I am saying let's create a dummy node. We created one dummy node, right? And initially our temp is, we have one more pointer which is temp, which is pointing to the same dummy node. Now what I am saying, after these initialization, that is pointer 1 pointing to list 1, pointer 2 pointing to list 2, and we created one more node which is a dummy node having content -1, right? And we have one more pointer pointing to this, we have one more pointer temp which is pointing to this dummy node, right? So now what we are doing after these initialization, what we can do, we'll keep on comparing the content of list 1 and list 2. We'll keep on comparing the content of list 1 and list 2. So let's compare. So the content of pointer 1 is 1 and the content at pointer 2 is 1, right? So that means they both are equal. We can increment any of the pointers. So let's say we are taking this 1 and we are incrementing this pointer, right? So we took this one. When we took this one, what I am saying, append this to the temporary dot next. So we have temporary which is pointing to -1 currently, but when we compared the data, I said I will attach this node to temporary dot next. So let's attach this to temporary dot next, which is 1, right? And also let's move our pointer, let's move our temporary pointer to 1 position ahead at this point, right? So now again we'll compare the content at pointer 1 and the content at pointer 2. Whichever is smaller, we'll append the next to the same, right? So let's see. So 2 is greater than 1. That means we'll take this 1 at this point and we'll move the pointer 2 ahead, right? So let's move. So we'll move this pointer at this 3 and we'll take this node 1. So what we'll do, we'll again append temp.next with temp.next as 1, right? And we'll again move this temp to 1 position ahead, right? Now currently the position of pointer 1 and pointer 2 is at 2 and 3. Again we'll compare whether 2 is smaller than 3. Condition is true. That means we'll take this 2 and we'll append it to temporary dot next. So append it to temporary dot next and move both the pointers. That means 1 to this position and temporary to this position, right? Again we'll compare 4 with 3. Since 3 is smaller, what we'll do, we'll take this 3 into temporary dot next, and then we'll increment our both pointers, right? Again both the pointers at 4, so we can take any of the node, right? So let's take this 4, right? And we'll move this 1 to 1 position ahead. So let's append 4 to temporary dot next and let's increment our 1 pointer to this and temporary pointer to this, right? Again at this position our pointer 1 has become null, right? If your pointer 1 has become null, that means we can directly append the content of second pointer to next of temp, which is 4, right? And we'll increment our this pointer to this point and this pointer to this point. Now at this point we have both the pointers pointing to null. So that means we can stop our processing and we can clearly see that we have the resultant sorted list 1 1 2 3 4 4 and the head of the list is this one, that means dummy.next. So we can directly return dummy.next from this point, right? So what we did, we took two pointers, pointer 1 and pointer 2. At every point we compared the content of pointer 1 and pointer 2. Whichever is smaller, we attached it to our result list and we incremented our temp pointer 1 position ahead and the pointer from which we took the content 1 position ahead, right? And at the end, when we had the complete sorted list, what we did, we have this dummy pointer, so we returned this dummy.next, because this is the head of the resultant list. So now let's try to code this. So what we were saying, we'll take 2 pointers. So let's say we have these pointers as list 1 and list 2. We also created a dummy node. So let me create dummy node, list node dummy, list node having content -1, right? I also initialized one temporary pointer which is basically pointing to the same dummy node. So now what I am saying, I'll run the loop till both the pointers are exhausted. So list 1 is not equals to null or list 2 is not equals to null, right? Now what I am saying, so if we saw, we have pointer 1 which was pointing to null, but at the same time our pointer 2 was pointing to this 4, right? So that means this pointer is null. At some point our pointer 1 was null, so we directly took the second pointer's content, right? So if list 1 is equals to null, what we did, we in our temp.next we appended list 2, right? And we incremented our list 2 pointer as list2.next, right? Similarly, if list 2 will become null, we'll do the same thing for list 1. Else if list 2 is equals to null, we'll do the same thing, right? Now let's say both the pointers have some content, that means they are not null. So what we'll do, we'll compare the content list1.value. If it is less than list2.value, so we'll take list 1 node, else we'll take list 2 node, right? And after doing all this, we can simply increment our temporary pointer to its next, right? And finally, when this whole processing will get completed, we'll return dummy.next. Now let's try to run this. Okay, let's try to submit it, and it is accepted, right? So let's quickly discuss what we did and what will be the time complexity of this approach. So we had 2 pointers, list 1 and list 2, right? We created one dummy node, right, and one temporary pointer which was pointing to this dummy node. Now at this point, if both the pointers have some data, we'll compare the data, and whichever is smaller, we'll take this into a result list, right? And we'll increment the same pointer, right? Again we'll compare the data, we'll increment the pointer, and we'll keep on doing until both the pointers are exhausted. That means both the pointers will point to null, right? Now what will be the time complexity for this approach? So if you'll see what we are doing, in the worst case we can traverse the whole list 1 and the whole list 2, right? Let's say the number of nodes in list 1 in worst case can be n, and the number of nodes in the worst case in list 2 can be n. So what will be the time complexity? N for traversing list 1, n for traversing list 2, right? So the time complexity will be O of n. What will be the space complexity? Did we take any space? No. We appended the same node, right? Let's say this was the node, so we took this node and we appended it to our result list. So that means in this case the space complexity will be O of 1, right? So this is how you can merge 2 sorted lists into one sorted list, right? I hope you understood the concept, how we are moving our pointers, right? Why did we take this dummy node? So I hope you understood the whole process, and you learned something new from this video. So that's it for this video. Let's meet in another video with another linked list questions, right? Till then, keep learning. Thank you.